Hi, my name is Dan Bozzo, and we're back again with another screencast session in the Creative Technology Toolkit series. This is number 5, plus there's a couple of additional random ones about loading and additional things. And in this video, I'm going to look at why sorting text is cool and doing some interesting things with text, looking at translation and rotation, using openFrameworks C++ Toolkit. So without delay, I'm going to go to my folder for the CT Toolkit sessions, and these are downloaded from the GitHub repository. I'll put the URL on screen, and they're now in the apps, my apps folder of openFrameworks. And we're going to have a look at session 5, and in here it's a standard folder. If you're using PC or Linux, these are the 3 files that you're interested in: the header file, the CPP file, and the main file. And just in case, what we should be building is something that looks a little bit like this. So I'm going to launch this in Xcode. And I'm going to expand my window a little bit. And in my project, I'm going to have a quick look and walk through what's going on in the header file, because we're going to see something that we haven't seen in previous sessions, in that we're going to make a new class here. So the class that we're going to make is very, very simple. But as a way of explanation, very quickly, essentially a class is like a factory that will build an object that we might want. I'm going to do a longer example explaining about classes and why they're cool and how they can help structure the thinking and philosophy underneath your code. But in this instance, what we're going to do is build a simple container to analyze text. And in this example, I'm going to be using a couple of different text files and showing how we can sort through and process them in different ways, and using a couple of techniques around visualization to present them on screen in an interesting way. So we have our standard set of available functions and routines that openFrameworks provide us with a setup, an update, and a draw. And what we've added are some static booleans. So these are ways in which we're going to use sorting that provide detail of how we're going to run different sort routines and gives them names. We're going to use a routine called ofTrueTypeFont to load in a font. So we're calling this openFrameworks object and saying we want to name it font, and in a minute we're going to load in a font, and there's a couple of different options that you can use from that. We're going to make a string which is going to indicate our sorting type, where we're going to use these names that we've put in, and we're going to make a vector called words. It's going to take a type, and vectors allow us to make lists of different types of objects or variables. So we could make a vector of integers, a vector of points, a vector of images. And it's an easy way that we can assemble large amounts of information in one group as a list, almost like an array in a straight line. But we're going to make a vector called words that's containing our custom type, our class, that I'm going to walk through in a minute. Then we've defined a couple of functions of our own, specialist functions, one called setup words that we send it a string, one for process open file selection, because one of the cool things is we're going to scrape data from the web and play with that as well. And it's going to ask for a fileDialog result, which is a routine that openFrameworks contains that allows us to pop up a fileDialog, and we're going to have a string called file extension. We're also going to use the openFrameworks HTTP response to call text not only from the hard drive as a text file, but over the web. And if we get a response, we'll process that. And we have a boolean to say whether we're loading things or not. And one thing that we saw previously is the openFrameworks easyCam, which is a simple camera to allow us to do sort of first-person shooter type stuff very, very easily from the keyboard or from a mouse pad. We're going to name that cam. And to make it look nice and pretty, we're going to make it auto-rotate, so it spins around and does things automatically for us. And we're going to use these two floats. So decimal numbers called auto rotate degrees and rotate step, and this is going to tell us how fast our text is going to rotate around and also whereabouts it is. And then to switch that on and off, we're going to use a Boolean so it can be on and off. And one of the things that I like that helps me read my code is that if I have a Boolean, I put a B underscore in front of it so that when I'm reading through my code, I know that's the only thing that can be inside that variable, a true or a false value. Now, this thing that I was mentioning earlier, which is about a class called lyric_word. So we're going to make a vector of custom objects called lyric_word. And up here, I define the class. So it's a new kind of object that we're going to tell openFrameworks or C++ about. We're going to say we're going to make an object called lyric_word. And it can have certain things inside its way of encapsulating functions or variables inside an object that we can make multiples of. So we're going to say a lyric_word as an object can contain a string, which we'll call a word, and an integer called occurrences. And what we're going to do is when we take our text files, we're going to break them up into individual things and take each word and store it inside an object called lyric_word with the text for that word and then an integer associated with it of how many times that word occurs in our text file that we're going to load in. And doing it like this makes it very, very easy to manage. I know that implicitly individual words are paired with a number of occurrences of them. And we could use this for a whole range of different examples. What we can then do also potentially is add functions in that this object understands how to do, and we just pass messages to the objects. But essentially the class is like a little factory, and I can say, please make me a new thing of the kind lyric_word and set this stuff inside it. And we're going to take lots and lots of these lyric_word objects and put them inside our lyric_words vector called words. So I'll have a whole string of these new objects. Inside each object it'll have the name of a word and an integer indicating how many times that word occurs in our text. And hopefully as we go through you'll see how they get used, but I am going to do a thing about classes because initially they can look complicated and take a little bit of time to understand about how to use them, but very, very quickly they're a great thing to be able to use to help you think philosophically about how you will organize what it is that you want to make. As the coding becomes less important and the syntax becomes less important, it's really philosophically how you think about what things are related that will help you build understandable code. So, going to our CPP file, the setup is not that long, and there's lots of comments all the way through. The first thing that we're going to do is add true type font. We're going to set that we want to use a global DPI, so this is within the whole program of 96 dots per inch, and then we're going to say load the typeface in. And I've commented out in the source code, if you've downloaded it, a couple of different options. We're going to use font, which is our true type font object we made. We're going to use its load method, it's a thing that it knows how to do, and ask it to load in a monospace typeface at 18 point. So these are system typefaces, sans serif, serif, monospace, that Mac, Windows, Linux will understand, and they're defaults. We could actually use a specific true type font by giving it the name of true type font and loading that into the data folder or at a specific file path. But in this instance, we just want this basic typeface. Now, we set up sort type info as an option, and initially we're going to use the option to say no sort. And now what we want to do is load a text file into a buffer and then into our content. So we're going to use the openFrameworks buffer object, which is a place that we can load things in. We're going to make a new one called buffer, and we're going to use the method buffer from file and ask it to load in this text freshprints.txt. And for a whole range of unexplainable reasons, this is the lyrics to the theme song from Fresh Prince of Bel-Air. So a large amount of what I'm working on here is actually built upon the fantastic example that comes with openFrameworks, and I've added a couple more things to make it a little more interesting and push it a little bit further. But the original example is actually coming from the openFrameworks examples, which I really do recommend you go and have a look through in the examples folder of your install. Now, the freshprints.txt file, because we're not giving it an explicit file path, openFrameworks will look inside the data folder. So if I go to my session 5 folder, inside the bin folder where our binary will be built is a data folder, and you can see I've got the fresh prints text in there, and here are the lyrics to the theme song for Fresh Prince of Bel-Air, and I've also put another text file in there, which is actually the Declaration of Cyberspace by John Perry Barlow, which he issued in the 90s, talking about big ideals. So this is from 1996 that he wrote at Davos, and there's a recording of him which is kind of interesting. It's a really interesting document to go back and look at for a variety of different reasons of the hope and the promise from that period. So that's where we're loading the text from, inside the data folder, inside bin. So we will ask our buffer object that we just made, called buffer, to load from file this text, and then from the buffer object, which can contain a variety of different things, we ask it to give us the text and load it into a string called content. And then we run this routine called setup words on our string that now has all the words from the Fresh Prince of Bel-Air. I'm just going to finish going through the setup here, and then we'll go and have a look at this first function. So we're going to set a couple of booleans. The loading is false, and this identifies whether we're trying to load something from a web URL. And then we set up our auto rotate and boolean to say we're going to start our auto rotating at 0 degrees, and the rotation step, how much that degree rotation is going to increase, is by 0.1 each time. But initially we're going to say have the auto rotation be false. In our update we're not going to do anything, and I'm going to skip straight down to this important one of setup words. So if I scroll down, you'll see there's key presses and a couple of other things, and here is a little bit further down our function that we've defined called setup words that retrieves or receives our string of content with all the words inside. We have made a vector called words that's expecting these word objects inside it from our header class lyric word. So here we defined a vector called words with our custom objects inside lyric words. And the first thing that we do is do a method that we can use on a vector is to say clear it and empty it, make sure it's empty. And then what we're going to do is go through the content and split it up. So we're going to use the of string replace to go through our content string, which has all the words in, and we're going to split it up by spaces, and we're going to find all of the new lines as well and turn them into spaces, so we have a complete ready-made tidied up string of content. And then we're going to go through and make content and split it up using the of split string function, which provides a content string. So this is all our lyrics in content. And then we're going to say split it by the spaces. And we have a couple more options. And it's going to put all of that into a vector of strings called split strings. Now we loop through all of the individual words that are now in this vector. So we've taken out a long string of content, we've taken out all the line returns and so on, and then we've split it into individual words by looking at where the spaces are in the split string call here. So we loop through however many words there are inside split string. And we find that out by saying splitString.size, and that returns the length of our vector. And we loop through. The first thing we do is we're going to make a new object using the lyric_word class that we defined here. So the lyric_word class, inside it, will have a string called word and an integer of occurrences of that word. So we can call lyric_word, and openFrameworks, and in this instance also Xcode, registers or understands that that's an object that it now understands about, and we're going to make a new one called word. Initially, we're going to set the occurrences of that word to be 1, and then we're going to set the word inside our lyric_word object, change everything to lowercase, and we're going to take the next, or the first in this instance, word that's been put into our split string variable here, where we took our long list of content, which is all the lyrics, split it into individual words, and now we're going to transfer one at a time into our words vector using pushback. And this takes our word object, lyric_word, and pushes it on to the end of a list of words in our vector. So our vector gets slowly longer and longer and longer, and each space in the vector is filled by this object lyric_word, and inside that it has a word and the occurrences of the word. So we're going to go through again, and we're going to have a look at all the words, and this time we're going to loop through to the size of the words vector. And here we have a list of simple characters to ignore, and if we find one of those characters, we use string replace and remove that string at whatever position we're in. Now what we want to go through is we loop through again all of the words inside the word vector. And initially we set the count to be 1. And we take the first word that we're working on and then loop through all of the others. And if they're equal, if we find a new occurrence of a word, we increment our word occurrences counter, which we're using C for here. And in that position, we increase the occurrences integer to show how many times we found that word inside it. Now, because we can get duplicates, we're going to go through all of the words inside our vector and take out the duplicates. So we loop through again all of the words inside our words vector, and if one word equals the other, we ignore it, and if it doesn't, we add it onto the back of our temporary word list. So we make a temporary list of words, put everything into them. We're setting a boolean here to say we should add the word by default, but if we found one that's already there, we add the boolean to false, and we don't do this pushback to add the word onto the end of the list. And then we replace all the words in our word list with the temporary ones where we've gone through, and if there's a duplicate, we don't add them. So quite a few things going on there, but essentially it's sorting. We've taken our lyrics and loaded it from a text file. We've removed spaces and the line returns and this list of commas, semicolons, underscores, exclamation marks, other pieces of punctuation. We've broken it into individual words in a vector, and then we've added them into our word list vector, and then we've gone through and counted how many times those words occur and added that alongside the words in our custom class object where we can have a word and the occurrences of that word. And then we've gone through a third process of looping through, find the first word and check all the other words in the list to see if it's duplicated. Second word in the list, check the rest of the words to see if it's duplicated, and so on. So we've ended up of a list of the individual occurrences of the word and only one copy of each word in the lyrics. And we've taken out the extraneous punctuation that we don't want. So a couple of processes there, but once we've got this, you can see how we're making comparisons of one word to another and counting through. And that gives us a vector with the individual words and the occurrences of the words. And the first thing that we're going to do is actually do something slightly more interesting with that, which is coming to draw. Because we have our easyCam object, and we're only going to be drawing in 2 dimensions, but with the easyCam object we can then tilt and look around that and make it look a little bit more interesting. I'm going to say cam begin, so it begins running the easyCam, and then I'm going to set a color to be red, and you'll see in a moment that this changes the first word that we draw on screen to be red. And we're going to use push matrix because we're going to do some rotation to try and get the words to run around in a nice circle. And rather than trying to do all the calculations of where each individual word would be, we're going to use push matrix and its corresponding command pop matrix. Basically what it does is say, freeze where everything is, allow us to do some calculations on an individual element, and then pop back to where we were. So I can say, take an object, let me find a useful object, take an object, freeze everything that we are, rotate this object, and then unfreeze, and we'll go back, and then I can do the same again and again and again, and you'll see how this builds up very, very easily. So I've told it to push and freeze everything that we're doing. I've made a float which is going to contain the radius of the circle of words that we're going to draw. And then I find out the number of words and divide it by 2. And I do some simple calculations here to say how big do I need the circle to be and how far round do I need to move each word as I count through, which gives me an X position and a Y position. And then what I do is I push the matrix again, and I'm going to draw an individual word here because I'm looping through all of the words, and I'm going to draw them one at a time and do a calculation to say how far around should I rotate to make this word fit into a circle. Now, if I've said that I want to auto-rotate these words, so which is when I've drawn it, the whole thing is going to spin, which you'll see in a minute. I'm going to use auto-rotate in the Z-axis, which is into and out of the screen, and also a little bit on the Y-axis, which is up and down, so you'll see it spinning in 3 dimensions. I'm going to use this calculation here where I've looked at the radius, and I'm going to use OF translate, which means I'm going to move in an X and Y direction the whole drawing plane, and then I'm going to rotate in the Z direction. This calculation that I've done here, I'm going to scale where I am, and then I'm going to use font, which is the font object we loaded earlier, which is just up here. We told it to load a monospace typeface, but this could be any other name typeface, or try out the sans serif or the serif typefaces. And I'm going to use font and the method drawString to draw whatever word we're at as we count through our vector of words at a position. So it will effectively freeze the screen, slide it to one side, rotate it, and then draw our word. And then it'll call pop matrix and pop it all back. So our word will appear to us to have been written like this, but because we freeze the screen, rotate it, translate it, and then draw, when we use pop matrix, it'll come back and our word will appear at that rotated offset place on the screen. We'll keep doing that, and because we're counting through the words and using that position to work out where we should be mapping, we'll count around and increase that rotation and offset as we go through. After we've drawn all of this, we change our drawing color to be black. So the first time we run through our draw loop, we set red, so the first word will be drawn red, and then we draw black. And then after we've gone through our loop here, which is running through all of the words in the words vector, we set our color to be white, and again we use our font and drawstring, and the sorting type info which we set up earlier will draw in the middle. And then we use draw bitmap string just to draw this simple string of explanation on the screen. Here I've added in a little routine which is talking about our auto rotate. I said we'll use a boolean, and I can tell it's a boolean because I've got this b underscore on the front of it. If boolean auto rotate is true and auto rotate is less than 360, I'm just going to use this to count up to 360 and start again at 0 as we go round and round. Auto rotate degrees plus equals the rotation step. So we add the rotation step that we set up earlier into auto rotate degrees. Auto rotate, as we saw in our setup, starts at 0, and every time if auto rotation is true, we add 0.1 to it. And if we've reached 360, we set it to 0. So in steps of 0.1, we're just going to keep rotating around. And we use this number to rotate the words as we're drawing through them. Now, let's run this and have a quick look. So I'm going to build and I have my text on screen. Initially, as you saw in the code, we just pull the text in from a text file. We run through, split out all the punctuation, take all the line returns and turn them into spaces, and split the words into a vector of words by finding the spaces, and then we remove the duplicates. All we've done here is taken the words and run them so they actually appear pretty much as they are in the lyrics. If we start from down here, or because I've got the easyCam, I can actually click on the screen and rotate this around, which is kind of cool. And because it's easyCam, it rotates a 2D drawing in 3D, which looks kind of nice. And running backwards is, now this is a story about my life began, da 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 da. As we go around, gives us sort of pretty much the lyrics without duplicate words and without if, the, and punctuation in there. So that's very nice, and you can see how the first word in that series is drawn in red, and then after that we loop through in black. Now on screen I've got the instructions here, and in the key press function you can see there's a couple of given traps we've put in for key 1, key 2, key 3, key 4, and at key 1 if I press it there's no sorting, but if I press key 2 we go through and sort alphabetically. So we start with the numbers and then go from A all the way around up to, well, in this instance, the highest letter of the alphabet that we're using is M. What we can also do is we can look at word length. So if I press key 3, you can see that we start with the longest word running down to the shortest word. And I can spin this around and have a look at it. Now, also on key 3, key R is a function that turns the Boolean auto rotate from false to true and true to false. It toggles it, and it uses my auto rotate where I'm taking the rotation degrees and, if you remember, just adding 0.1 degrees every time. So I can have this very attractive looking spinning word piece, and as I'm doing it I can dynamically make it sort on different words. I'm going to come back to our source code for a moment and just have a look at a couple of other things that we have in here that allow us to bring in text from other places and do a couple more things to it. So coming back to my code, you can see in key pressed, if the key is 1, I change the sort type variable to no sort. If the key is 2, I change the sort type variable to sorting alphabetically to read the text, and I use this function ofSort, and then the static boolean earlier, we sort on ABC, or key 3 is sort on length. We call the same function here, passing it a words vector, but ask it to sort on occurrences. And if I come down to my sorting, here are defined the various sorting functions, and you can see actually they're pretty simple. The first one, sort on ABC, it goes through the lyric words, comparing them, and if one is greater than the other, it returns them. On length, it uses the size integer inside our lyric word object, where it compares one word against the other by saying if one is greater than the other, that gives us our order and returns the order. And then it goes on the occurrences integer, which we sorted through earlier, of comparing one word against another. So that gives me the ability to do 3 different simple sources by either comparing the length of the words or the occurrences integer that we put in. And if I come up to my key press function again, we've added a couple more in. Here, right at the bottom, you can see if the key R is pressed, I'm using this feature to say just toggle make auto rotate equal to not auto rotate. So if it's true, it becomes false. If it's false, it becomes true. And then if I press the key F, I'm using this function from openFrameworks we've seen before, toggle full screen. So if it's full screen, it'll become windowed, and windowed become full screen, etc. And then I have 2 more. If I press the L key, it'll open an openFrameworks file dialog with the text, select a text file, and it'll put the result of that open file dialog into file result. And that says whether the user cancelled a file, whether we were successfully able to load a file, etc. If the file result here is successful, just as a debug, I'm going to output a text message to say, yes, I've opened a file, and then we've written a file routine to process the open file selection. If that's not successful, it means the user hit cancel, and we debug that. The second piece that we have here is if I press the W key, I'm using the openFrameworks Hypertext Transfer Protocol HTTP response to say try and load something using the openFrameworks loadURL function from this URL. So if you've got a file, a text file, anywhere on the web that you want to try and load, just replace it in here. Here, what I'm actually doing is I'm going to google.com and I'm loading their robots.txt file because I'm pretty sure that's going to be available. And it's kind of interesting to go and scrape something from Google. I think I'm allowed to do that. So we try and load a URL. It gives us a result, and we load it into an openFrameworks response object, and then I actually ask it to output the load result, and I use a function called URL response to see what the response of that was. Either it might be an error from the server saying that file's not available, or hopefully it's the file itself. So let's go and see in practice what happens when we use those two. Here I've loaded up and run my application again. I'm going to press the F key to run it full screen, and I can have my auto rotate, which is kind of pretty, and if I hit 2 I can sort it alphabetically or on word length, which is really nice. The thing that I'm going to do now is I'm going to hit the L key, which is going to ask for a load file dialog. So we use the openFrameworks load file dialog, and the result of this operation is going to go into the load file result. And inside my bin folder, inside the data folder for session 5, I've got my original text for the Fresh Prince of Bel-Air, but I've also got my other text, the Declaration of Cyberspace. But you could look across your hard drive and find any other text file and load that in yourself. In this instance, I'm going to load in the Declaration of Cyberspace from John Perry Barlow. And it loads in my text, and you can see there's a lot more text in here now. And I can go through and sort alphabetically or on word length. And if I hit R, I'll stop the rotation, and you can see the words loaded from John Perry Barlow's Declaration of Cyberspace. It might be useful perhaps with the longer text to make the radius bigger or to scale down the typeface that we're using, but you can play around with that internally. Now the other thing that I can do is if I press the W key, it'll run through my routine where it's saying please use the HTTP response on the openFrameworks load URL, where it'll go to a specific URL that you tell it and try and load that in. Then we analyze the response to see, has the server fallen over or is it giving us our file? And if I press the W key, very, very quickly, it's gone off to google.com/robots.txt, and you can load this in a browser right now. And it has returned me, if I make this stop rotating, a whole list of URLs that's in that robots text about what can and can't be followed by robots that are scraping google.com. So if I put this alphabetically, you can see it's listing directories of all kinds of stuff. So Google, from Google Maps to Google Ads to Google Analytics to Google eBooks, etc. And I can play around with that, rotating it and sorting it as I like. So there's quite a lot going on in here. We've seen how we can load text from file, and then we can go through and break that text into individual words, put it into a vector, and then do operations on that vector. Finding the occurrences of the words, finding the length of the words, and then being able to sort using push matrix and pop matrix, where we can draw things to screen, freeze where the screen is, rotate, move around, write our object to screen, and have it come back, so we can do complicated looking displays with just very few options. We've seen briefly how we can use the open file dialog from openFrameworks to load in text files, or this could account for images or other kinds of files that we want openFrameworks to know about, and also about using loadURL to attempt to load from a server. I'm not going to go through every single piece of the code. Please do slowly walk through it, and I recommend that you have a look at the other examples in the openFrameworks examples folder, and also use openFrameworks.cc for the project documentation for each of the individual commands, which will tell you in detail what kind of variables can be passed and exactly how some of these functions can work. But hopefully you've seen why actually sorting text kind of gets interesting, and you can play with it and do wonderful things. And some of the range of complexity that you can build with openFrameworks very, very quickly. All of the source code is available online at GitHub, and the URL will be on screen. And I'll keep posting more videos. If you have any questions, queries, corrections, please do put them into the comments, and I look forward to seeing you on another video. Thanks.